We're going to talk about complex numbers today. And what we're going to do is once we learn about complex numbers, we're going to take what we know about complex numbers and then apply them to solutions to polynomial equations. They have something to do with polynomial equations. Now the reason that we're talking about complex numbers is we've been working with polynomials, a very simple quadratic equation, x squared plus 1 equals 0. Can we solve this with techniques that we've used so far? We get x squared equals -1 and take the square root, and x equals plus or minus the square root of -1. Do we know what the square root of -1 is? I. So we know what it is, but if we were to trying to come up with a solution like we've done on the board so far, that really doesn't give us much information. What is the graph of this? If we graph this equation, what would the graph look like? Just a quick sketch. X squared is always what kind of shape? Parabola. And what does the plus 1 do? Shifts it up 1. So my parabola looks like this. Just a rough sketch. So it's a parabola shifted up 1. It never crosses the x-axis. So that's one thing that the fact that we get a -1 here tells us, that it never crosses the x-axis. So what we're going to do when mathematicians first came up with this problem where we had this thing square root of -1, we didn't know what it was, so we said, well, let's just call it something. So we're going to say that square root of -1 is I. We can just call it this letter I. Now, it's unfortunate that we call it I. We call it an imaginary number, because it's just imaginary just means a name. It doesn't mean it doesn't exist. That's just what they happen to call it. So I is called the imaginary unit. I is the square root of -1, and if I square both sides here, that tells me that I squared is -1. So I is this number. When I square it, I get a negative number. So this is what we're going to be working with today. So any number, and we've talked a little bit about imaginary numbers before when we did polar form of complex numbers. So I squared is -1. When we put real numbers with imaginary numbers, we get complex numbers. So the complex numbers we write in the form a plus bi, where a and b are real numbers. We call the a part the real part, and we call the bi part the imaginary part. So a is the real part, the bi part is the imaginary part. So I'll just put that up here in red. So what we're going to do today is just kind of remember how we work, our basic ideas of working with complex numbers. So to add complex numbers, we'll start easy, and we'll start by adding complex numbers. Something written like this. This is the real part. This is the imaginary part. So to add them, anybody remember what we do to add complex numbers? Add the real part together and add the imaginary part together, and we keep them separate. So if we have if we write in general a plus bi, and we're adding c plus di, we have these two complex numbers. That's going to be a plus c will be our real part. We add those two parts together, plus, and then we add the imaginary parts, b plus d, and that's going to be our new imaginary part. So we just add the real parts together, add the imaginary parts together separately. And if we subtract complex numbers, basically we're doing the same thing. We just subtract the real parts and subtract the imaginary parts. So just a quick example, if we were saying 6 minus 3i plus 1 plus 2i, what would I get here? If I add the real parts, what do I get for the real part? 7. And for the imaginary part? -1. -3 plus 2 is -1. So I get 7 minus I. Added the 6 and the 1 to get the 7. Added the -3 and the 2 to get the -1i. And if I'm subtracting, just a quick subtraction example, 5 minus I. Minus, and when we subtract, it is very helpful to write our second number in parentheses, minus 2 minus 4i. So if I do this subtraction, what's going to be my real part? 5 minus 2. So I get 3. And for my imaginary part, I have -1 minus -4. 5i. -1 minus -4. So what do I get? Positive plus 3i. -1 minus -4 is -1 plus 4, which is 3i. So my answer comes out to be 3 plus 3i. So this should be easy. Multiplying. Who remembers what we do to multiply complex numbers? FOIL. So before we FOIL, let's look at a really easy example first. So if we multiply, we use the same rules that we do for real numbers. Just we have to keep the real parts and imaginary parts. We have to take care of them kind of separately. Well, let's do an easy one first. What if we just had 2 times 17 minus 5i? What do I do here? So Alex says we just distribute the 2. That's the way we usually thought about. I have parentheses. I'm just distributing the 2. So I get 17 times 2 is 34 minus 10i. So if I just have a number out here, I just distribute. And Parker says if we have something more complicated, 3 minus I times 5 plus 4i. To do this, we're going to FOIL, and then we simplify. So we'll have a little bit of work to do. So for my first I get 15. For my outside, I get plus 12i. For my inside, I get minus 5i. And for my last, I get minus 4i squared. So I'm going to combine the parts with the I, so I get 15 plus 12i minus 5i is 7i. Minus 4i squared is what? Negative 1. So I have, I'm writing more steps than you really need to, but 15 plus 7i plus 4. So I get 19 plus 7i. All right, so when we multiply, we FOIL and simplify. Questions on multiplying complex numbers? Should be more or less review. Just kind of a reminder of how we do this. Now, when we divide complex numbers, it gets a little more complicated. So we need to talk about one other thing before we divide complex numbers. The complex conjugate. So if we have a number a plus bi, does anybody remember what the complex conjugate is? How do we write the conjugate? The complex conjugate to any complex number is, so a plus bi is a minus bi. Basically, we change the sign on the imaginary part. So the idea for the complex conjugate is we change the sign on the imaginary part. Now, one nice thing about the complex conjugate is if we multiply a complex number by its conjugate, we get a real number. So that's one reason why it's useful. Complex conjugate, if we multiply the complex number by its conjugate, we get a real number. And what we use the complex conjugate for is to divide complex numbers. So dividing complex numbers. So if we want to divide complex numbers, what we do is we multiply the numerator and denominator by the complex conjugate of the denominator. So I'm going to say multiply top and bottom by the complex conjugate of the denominator. And we'll do a couple of examples, and once we do a couple of examples, it'll make sense. It's not a difficult thing to do. It's kind of like we do when we rationalize denominators with radicals. We just have this complex conjugate. So if we wanted to divide 2 times 1 minus I, I'm going to multiply the top and the bottom, the numerator and denominator, by the complex conjugate of the denominator. So I'm going to multiply by 1 plus I over 1 plus I. And when I do this, I strongly suggest that you write parentheses so you remember that you have to multiply out these parentheses. So let's do this. Now we've turned this division problem really into a multiplication problem. So on the top, when I multiply here, I'm just going to distribute. So I get 2 plus 2i. And on the bottom, I'll have a little work to do. I need to FOIL this out. So for my first, I get 1. For my outside, I get plus I, and I'm going to write out all the steps here. If you can probably shorten the number of steps. For the inside, I get minus I. And for the last, I get minus I squared. So I get 2 plus 2i. And the plus I and the minus I cancel. That's why we multiply by the complex conjugate. And I get 1 minus I squared is negative 1. So I get 2 plus 2i over 2. And what can I do with that 2 now? I have a 2 here, a 2 here. I have a 2 in every term on the top and 2 on the bottom, so I just get 1 plus I. I can divide everything by 2. So dividing complex numbers means we multiply the numerator and denominator by the complex conjugate of the denominator. And then we simplify our answer. Now that we know a little bit about complex numbers, now we can solve any quadratic equation. So let's look at a really easy example of using complex numbers with a quadratic equation. So just a really short example. So if we were to solve x squared plus 9 equals 0. So how would we go about solving this? What would we do? Subtract 9 from both sides, so I get x squared equals negative 9. Take the square root of both sides. So x squared equals, and what happens when I'm solving an equation when I take a square root? What I have to be careful of? Plus or minus. Square root of negative 9. And I can rewrite square root of negative 9. This would be x. X equals plus or minus negative square root of negative 9. So I'm just I'll write another step here. Plus or minus the square root of negative 1 times 9. What's the square root of negative 1? I. What is the square root of 9? 3. So plus or minus I times 3. And the way we usually write this is plus or minus 3i. When we use the quadratic formula, now that we were using this imaginary number, if we get a negative number inside our square root with the quadratic formula, we can write our answer with I in answer. So we can simplify our square root using the square root of negative 1 equals I and write that in our answer. So this gives us another tool for working with polynomials, and on Friday we will talk about how when we solve polynomial equations, what happens when we get complex solutions. So that's really all I have for today. Now we have two things to do today.